Hello. Today we will be working with inequalities. We're going to review properties of inequalities. We'll learn to use interval notation, and we're going to look at solving several different types of inequalities. Let's begin by looking at our objectives for today. First, we want to review our properties of inequality. Solve and graph linear inequalities. Learn to use interval notation. Solve three-part inequalities. Solve quadratic inequalities. And solve rational inequalities. Let's begin by reviewing our properties of inequalities. First, for real numbers a, b, and c, a is less than b and a plus c is less than b plus c are equivalent. Second, if c is greater than 0, that is c is positive, then a is less than b and ac is less than bc are equivalent. Lastly, if c is less than 0, then a is less than b and ac is greater than bc are equivalent. Now remember, we can replace our less than symbol with any of the variations of our inequality symbols, and our results are still valid. Let's look at an example of a linear inequality. A linear inequality in one variable is an inequality that can be written in the form ax plus b is greater than 0, where a does not equal 0. Let's look at this example. We have the inequality negative 3p minus 2 is less than or equal to 1. Now the first thing we want to do is to add 2 to both sides of this inequality. This results in an equivalent inequality, negative 3p is less than or equal to 3. Now we'd like to multiply both sides of this inequality by negative 1/3. Now remember, we must change the direction of our inequality sign. It now is a greater than or equal to sign. Simplifying leads to p is greater than or equal to negative 1. The solution, remember, is the set p such that p is greater than or equal to negative 1. We can look at the graph of this solution on our number line, mark the point negative 1, and since we want to include negative 1, we'll put a bracket there, and we'll shade in the number line to the right. Now here's a problem for you to try. Remember to write your solution as a set of numbers and to graph your solution on the number line. Let's look at this solution. First, we want to add 3 to both sides of the inequality. This gives us negative 5x is less than 10. Now we can multiply both sides of the inequality by negative 1/5. Did you remember to change the direction of the inequality sign? Now let's look at the graph of this solution. We have our number line with the point negative 2 marked. We have a parenthesis there since we do not want to include the value negative 2, and we've shaded it to the right. In set notation, this is the set of all x such that x is greater than negative 2. Now there's another way we can write the solution to this set of numbers. Did you notice that we have an interval here? We have a notation called interval notation, and it starts with our number negative 2. Our interval starts on the left and extends indefinitely, and we indicate this by using the infinity symbol. This is an example of interval notation. Again, it consists of 2 numbers or symbols, the smaller number or symbol on the left and the larger one on the right. Now in this case, we have parentheses around both negative 2 and infinity. We put parentheses around negative 2 since we do not want to include that value, and we put a parenthesis around infinity since we never reach that value. We call this an open interval. Here's another example of an open interval. The set of all x such that x is between 2 and 5. Look at the graph on the number line. We've marked the numbers 2 and 5. We've put parentheses around them and shaded the values between them. In interval notation, our 2 is on the left, our 5 is on the right, and again we have parentheses around both 2 and 5 since x cannot include those values. This is again an open interval. Let's take a look at this inequality. Here we have the set of all x such that x is greater than or equal to 1 and less than or equal to 4. On the number line, we've marked the numbers 1 and 4, and this time we've put square brackets around the 1 and the 4. This indicates that we want to include those values, and we've shaded in the values between 1 and 4. Now our interval notation will still use two numbers or symbols, the smaller numbers on the left, the larger numbers on the right. But again, notice this time we put brackets there since x can equal 1 or x can equal 4. We call this a closed interval. Here's another example of a closed interval. We have the set of all x such that x is greater than or equal to -2 but less than or equal to 0. Our two numbers again are -2 and 0 with brackets around both, and we've shaded the numbers between. Our interval notation begins at -2 and extends to 0. Again, we put brackets around both, and we call this a closed interval. Now sometimes we'll have inequality statements that contain both less than signs and less than or equal to signs. Here's an example. We have the set of all x such that x is greater than -2 but less than or equal to 5. We again mark our two numbers on our number line, -2 and 5. But this time we put a parenthesis around -2 since x cannot equal -2, but a bracket around 5. Our interval notation will start at -2 and extend to 5. Notice how we have a parenthesis on one side and a bracket on the other. In this case, we call this a half-open interval. Here's another example of a half-open interval. The set of all x such that x is greater than or equal to -2. We mark our number line with -2, put a bracket there since x may equal -2, and shade in all the values to the right. So our interval notation will have a value at -2 and extend to infinity. Again, notice we have a bracket at -2, a parenthesis at infinity, and we call this again a half-open interval. Now, from now on, when we solve our inequalities, we will write all of our solutions using interval notation. Now, another kind of inequality we can look at is a three-part inequality. For example, here we have -3 is less than or equal to 2x minus 1 is less than 9. We might say that 2x minus 1 is between -3 and 9. To solve this, we want to isolate x in the middle. So the first step would be to add 1 to each part of this inequality. This results in -2 is less than or equal to 2x is less than 10. Now we might want to multiply each part of the inequality by 1/2. This will give us -1 is less than or equal to x is less than 5. If we look at our graph on our number line, the two numbers we're interested in are -1 and 5. We want to include the -1, so we put a bracket there. We'll put a parenthesis at 5 since we don't include that, and we shade in between. In interval notation, our solution is the interval from -1 to 5, bracket at -1, parenthesis at 5, and remember we call this a half-open interval. Now here's another example of a three-part inequality. We have negative 3 is less than or equal to x minus 4 divided by negative 5 is less than 4. Now we want to clear our fraction, so the first thing we need to do is to multiply all parts by negative 5. Now remember, we're multiplying by a negative number, so we must change the direction of the inequality signs. This will give us 15 is greater than or equal to x minus 4 is greater than negative 20. Now we can add 4 to all three parts, resulting in the inequality 19 is greater than or equal to x is greater than negative 16. Now in interval notation, remember the negative 16 is the smaller number and it will go on the left, and 19 is the larger number, it will go on the right. We put a parenthesis around negative 16 and a bracket around 19. Looking at its graph, we've marked the two numbers on our number line, negative 16 and 19, parenthesis around negative 16, bracket around 19, and we've shaded in between. Now, inequalities can be used in applications, and one application is the revenue cost break-even point inequalities. We say that a product will break even if its revenue is at least as big as its cost. Let's take a look at this example. The cost to produce X units of radios is C equals 20X plus 300, while the revenue is R equals 30X. Find the interval where the product will at least break even. Now remember, C is the cost, R is the revenue, and X is the units of radios. Breaking even means that revenue equals cost. R is equal to C. At least breaking even means that R is greater than or equal to C. In our problem, we want to know when we at least break even, so our revenue, 30X, is greater than or equal to our cost, 20X plus 300. Subtracting 20X from both sides gives us 10X is greater than or equal to 300. Dividing both sides by 10 or multiplying by 1/10 gives us X is greater than or equal to 30. Our solution then is the interval from 30 to infinity. Again, notice the bracket around 30 and the parenthesis around infinity. Now, the solution of quadratic inequalities depends on our solutions of quadratic equations. So, our quadratic inequality is first defined to be an inequality that can be rewritten in the form ax squared plus bx plus c is less than 0, where a, b, and c are real numbers and a does not equal 0. Now remember, we can replace the less than sign with any of our variations of the inequality signs. Here's an example. We have the inequality x squared minus x minus 6 is greater than or equal to 0. The first thing we want to do is to find the values that make this inequality 0. So let's look at the equation x squared minus x minus 6 equals 0. Factoring gives us the factors x minus 3 times x plus 2 equals 0. Or the solutions that x is equal to 3 or x is equal to minus 2. Putting those on the number line, we see that the numbers negative 2 and 3 divide the real number line into 3 intervals. Let's look at the sign of each factor in these 3 intervals. Our first factor, x minus 3, is negative to the left of 3, positive to the right of 3, and is 0 at 3. Our second factor, x plus 2, is negative to the left of negative 2 and positive to the right of negative 2, but it is 0 at negative 2. Now, using our laws of signs here, if we look at the product of our signs, To the left of negative 2, both factors are negative, so the product is positive. Between negative 2 and 3, one factor is negative, one is positive, so the product is negative. And to the right of 3, both factors are positive, so the product is positive. Now, if you recall, we were looking for our inequality to be greater than or equal to 0. So we need to look at the intervals where the products are both positive. And those are the values of x that are less than negative 2 or greater than 3. Using interval notation, we'd have two intervals here. The left interval begins at negative infinity and extends to negative 2. Remember the parentheses around negative infinity and the bracket around negative 2. And the second interval begins at 3 and extends to positive infinity. Again, we put a bracket around the 3 and a parenthesis around infinity. Let's list the steps that we used to solve this quadratic inequality. The first thing we did was to solve the quadratic equation. Step 2 tells us to identify the intervals determined by the solutions of the equation. And step 3 tells us to use a sign graph to determine which intervals are in the solution set. Now, here's a problem for you to try. We'll pause the tape and let you try this. Let's look at the solution to this inequality. Our first step is to solve the quadratic equation, x squared minus 3x plus 2 equals 0. Factoring gives us x minus 2 times x minus 1 equals 0. And our solutions are x equals 2 or x equals 1. And we've graphed these numbers on our number line. Now the next step is for us to determine where our factors are positive or negative, so that we can find out where our product is positive or negative. To the left of 1, both factors will be negative, so the product is positive. Between 1 and 2, the factor x minus 2 is negative, while x minus 1 is positive, so their product is negative. And to the right of 2, both factors are positive, so the product is positive. Therefore, we know that our signs are plus when x is less than 1, negative when x is between 1 and 2, and plus when x is greater than 2. Now our inequality asks us to find the solution of the expression less than or equal to 0, so we're looking for all the values of x between 1 and 2. In interval notation then, this would be the closed interval from 1 to 2. Now, the last type of inequality we'd like to look at is a rational inequality. Now, this will require us to use some of our skills for simplifying rational expressions. Let's look at some guidelines for simplifying rational inequalities. Our first one is rewrite the inequality, if necessary, so that 0 is on one side. Make a sign graph with intervals determined by the numbers that cause either the numerator or denominator of the rational expression to equal 0, and determine the intervals or intervals of the solution set. Let's take a look at this rational inequality. 3 divided by x minus 6 is less than or equal to 2. Now remember, our first step is to have 0 on one side of the inequality, so we need to subtract 2 from both sides. Now we need to rewrite this expression so that we have one term on the left. Now to do that, remember we have to use a common denominator and write the expression as 3 minus 2 times the quantity x minus 6, all divided by x minus 6. And that, of course, is less than or equal to 0. Now we need to simplify the numerator, and in so doing, we get the expression 15 minus 2x in the numerator divided by x minus 6 in the denominator. Now our second step was to find out where the numerator was 0 or the denominator was 0. 15 minus 2x is equal to 0, or x minus 6 equals 0, when x equals 15/2 or x is equal to 6. Now these are the two numbers that we want to put on our number line. Here they are. Now let's check the signs of each of the factors. To the left of 6, 15 minus 2x is positive, but x minus 6 is negative. Between 6 and 15/2, both factors are positive. And to the right of 15/2, 15 minus 2x is negative, while x minus 6 is positive. Now our inequality asked us to find when our expression is negative. The sign of our quotient is negative to the left of 6 and to the right of 15/2. So our solution set, graphed on our number line, looks like this. We've shaded in all the values to the left of 6 and all those to the right of 15/2. Now notice, the original inequality said less than or equal to. We can put a square bracket around the 15/2, but we cannot put a square bracket around 6. If we did, then we would include a value which would make the denominator 0, and that's not valid. In interval notation then, our solution is the interval from -infinity to 6 union the interval from 15/2 to infinity. And again, note we have a bracket around 15/2 and parentheses around everything else. Today we've looked at several different kinds of inequalities. Now, one of the most important things to remember is that when we multiply or divide both sides of an inequality by a negative number, we must change the direction of the inequality sign. We've learned how to use interval notation, and we've also recognized that we need to brush up on our skills for solving quadratic equations and rational equations, as these skills will be used in solving quadratic and rational inequalities. Have a good day.